Today we are going to see speed control of DC shunt motor, and the aim is to control the speed of the given DC shunt motor by field and armature control method, and also to draw the character curve. This is the panel in which we have to connect the required equipments to do the speed control of DC shunt motor. And the apparatus required are ammeter, DC ammeter 0 to 2 amps, voltmeter 0 to 300 volt, and tachometer to find the speed, and 2 rheostat 300 ohms and 1.7 amps. And this is the 3-point starter to start the DC shunt motor, and this is the DC shunt motor, and the nameplate details of the shunt motor are here. You can see this is 5 HP motor, voltage is 220 volt, current is 19 amps, and speed is 1500 rpm. For the speed control of DC shunt motor, we don't need the load, so we are removing the load here. You can see this is circuit diagram. So as per the circuit diagram, we are going to connect the apparatus in the panel. So as per the circuit diagram, we are giving from main supply, that is plus to L. You can see the main supply to L. Next, see according to the diagram, we are giving from field to rheostat, and from rheostat to motor field, and also from motor field to that ammeter, positive and negative. As said, according to the circuit diagram, we have given from field to rheostat, and again from rheostat to motor field, and from motor field to, you can see this blue wire, that is from motor field to ammeter plus, and now from ammeter plus to, so from the negative of the voltmeter to the negative of the voltmeter to the negative of the supply, DC supply, main supply. Now according to the circuit diagram, we are going to connect from armature to the second rheostat, and from rheostat to the motor, and from motor to the negative of the main supply, and a voltmeter is connected parallel to the motor. You can see from the armature, it is connected to the rheostat, and from the rheostat it is connected to the motor, and from motor one is connected to the minus of the supply, and you can see the voltmeter is connected parallel to the motor as per the circuit diagram. And as per the circuit diagram, the armature side of the rheostat is kept in maximum position, and the field side is kept in the minimum position, this rheostat. Now after the connections are finished, by using the 3-point starter, we made the motor to run in the rated speed, that is 1500 rpm. So the motor is bought by adjusting the armature side rheostat from maximum to minimum position, and also the field rheostat is also adjusted to bring the motor to rated speed. Now we are going to do the armature control method, and we are keeping the field current to 0.5 amps, and this is the tabular column for armature control method. You can see speed in RPM, armature voltage, and field current is constant 0.5 amps. Now the voltage is, you can see, 192, and the speed is 1490. Now we are adjusting the armature side rheostat and keeping the voltage to 180 volt. So for this, speed is 1400 or 1406. We are adjusting the rheostat in the armature side, and we are going to keep the voltage to 160. And the speed is 1260 RPM. So we have taken 3 readings here, and by adjusting the armature side rheostat and keeping the voltage to 150, 140, 120, you can take more readings by calculating the RPM. Now we are going to do the field control method. In this method, we are keeping the voltage in the armature side to 190 volt, and the field current is, you can see, 0.5, and the speed is 1498. Now we are adjusting the field rheostat and keeping the field current to 0.46, 1550. So you can see in field control method the speed is increasing. Now by adjusting the field rheostat, and we are keeping the field current into 0.4, you can see the speed is high, that is 1634. Now you can see in the field control method, when the armature voltage is 190 volt, that is constant, you can see when the field current is decreasing, that is 0.5, 0.46 and 0.40, you can see speed is gradually increasing in the field control method. You can see 1490, 1550 and 1664, but in the voltage control method, that is armature control method, you can see the speed is decreasing. When the voltage is decreasing, the field is also, that is speed is also decreasing. The full procedure, aim and the calculations and the graph is given in the another video, and you can watch the link in this video. Thank you.